Dear friends, I myself, Dr. Bharat Parab, discussing the topic visualizing solid shapes, and now we are trying to solve some problems on this topic. First one, can polyhedron have four faces? First one, three triangles. Second, four triangles. Third one, a square and four triangles. What does this mean? Means can polyhedron have three triangles? Okay, we will tackle one by one. No. Answer is not possible. Polyhedron is not possible with three triangles. Second one, four triangles. Answer is here. Yes, it is possible. And I have drawn it for you. And the third one is a square and four triangles. Square and four triangles. Yes, it is always possible. This is a square and four triangles. Okay. That is also a polyhedron. Okay. Second one, read this very carefully. Try to understand this. Is it possible to have a polyhedron with any given number of faces? In this given, think of pyramid. What does this mean? That means how many minimum number of faces are required to have a polyhedron and maximum number of faces. Okay, it's talking about this. Any given number. Okay. So with this, we go for the answer. Clearly, we need at least or minimum four faces. See diagram. Okay, this is a triangle and there are four faces is here. Okay, third one is backside. Now, second part. This is the minimum number of faces. Then we will see the maximum number of faces. Okay, as we increase the number of sides of base to infinity, there are only three sides. We can have 4, then a face will increase, then 5, another face will increase, 6, another face will increase. Okay, so this comment says the same thing. As we increase the number of sides of base to infinity, number of faces also increase to infinity. Okay, and this is the actual answer given. This was the explanation and this answer. Hence, we can say that it is possible to have polyhedron with given number of faces, but minimum four faces. Okay, clear? We move to the third problem. Third one, which are prisms among the following? This nail is given, unsharpened pencil, and third one is a table weight. We generally call it as paper weight, and fourth one is a box. Okay, so before going to this, try to understand the definitions of prisms and pyramids. Then it will be very easy. So I'm going directly for the answer. One is not prism as top is a round shape. Got it? Okay. Now read this definition once again. Try to understand this. Okay. Then we will come to know this. Okay. Now second one, unsharpened pencil, and we'll see about the third first. Table weight, that is a pyramid. Okay, and 2 and 4 are prisms. We are supposed to see which are prisms, 2 and 4. Okay, and see the definition of prisms and pyramid, and you will understand this properly. Okay, fourth one, first part, how are prisms and cylinders alike? And second part, how are pyramids and cones alike? Try to understand this properly. Is comparing about prisms and cylinders and trying to say that they are alike, and comparison between pyramids and cones and trying to say that these two are alike. Okay, so directly tackling answer. First one, prisms look like this is a prism, this is a prism. Okay, and pyramids look like this. Okay, clean our basis of all. Okay, then actually the comment comes, increase in number of sides, of course, of base to infinity, a length of side becomes very small. Okay, so it is given here, base sides are 3, then if you increase this to 4, 5 or 6 and go on increasing like this, you can see how length decreases. Here it is this much, here it is very small. Okay, so like that, if you increase the number of sides to infinity, then length becomes very small, almost tending to 0. Okay, so that base becomes a circle, so that this becomes almost a circle. Okay, and when this base becomes circle, it will look like this, that is prism's base. If it is circle, it will look like a cylinder. Hence he said prisms and cylinders are alike. Okay, and the pyramid, if the base of the pyramid becomes circle, it will look like this, like cone. That is why he says pyramids and cones are alike. Okay, got it? Hence prisms and cylinders alike and pyramids and cones alike. Okay, so we go ahead. Now fifth one, is square prism same as cube? Answer, let us see the difference between square prism and cube. Look at these diagrams. This is a square prism and this is a cube. Okay, and go to the comment here. Clearly square prism has only square base shaded in blue. Okay, and sides parallelogram. Okay, these are the parallelograms. Okay, and cube has all sides equal. Okay, hence its all the faces are square. Okay, now you can think the difference between these two and answer this. So they are not same. Okay, the sixth one, verify Euler's formula for these solids. There are two solid structures given. Okay, and we have to verify Euler's formula for this. You know, this is Euler's formula, F plus V equal to E plus 2, where F stands for number of faces, V for number of vertices, and E for edges. Okay, so answer for this, for first one, F is equal to number of faces, 5 faces on sides and 2 top and bottom. So 5 plus 2 is 7. V, there are 5 on top and 5 at the bottom. So 5 plus 5 is 10. And E stands for edges. There are 5 at top, 5 at bottom, and 5 on sides. So 5 plus 5 plus 5 equal to 15. Always try to follow this technique, because if you write directly, there is nothing wrong, but you cannot verify whether these are wrong or right. So this is a nice technique. Okay, so we go ahead for Euler's formula for this. Okay, F plus V equal to E plus 2, where F is 7 plus 10 equal to E is 15 plus 2. This is 17. This is 17. Okay, it satisfies for this, and we will now check for second one. Okay, now F, number of faces are 4 plus 4 plus 1, 4 at top, 4 sides, and 1 bottom. So 4 plus 4 plus 1 is 9. Now vertices, okay, 1 plus 4 plus 4, so 1 plus 4 plus 4 is 9. And now edges, very simple, 4 at on this, then 4 this top, 4 bottom, and 4 sides. Okay, so 4 plus 4 plus 4 plus 4 is 16. Now apply or verify or try to substitute these values in this formula. A plus B equal to E plus 2. 9 plus 9 equals to 16 plus 2. This is 18. This is 18. So it's satisfy for these two. So satisfies the equation, hence follows Euler's formula. Okay. Seventh one, using Euler's formula, find the unknown. This is very simple. Actually, faces, vertices, edges, FVE. So this is unknown. This is given. This is given. You can check this table. Okay. We will directly go for the answer. Answer Euler's formula is F plus V equal to E plus 2. If you take this first one, F plus V equal to E plus 2, F is to be determined, plus 6 equal to 12 plus 2, this is 14. So F equal to 14 minus 6 is 8. The answer is given here. Copy it down the table here, and this answer is given here and marked in yellow. Okay. Second one, F plus V equal to E plus 2. F is given, V is to be found out, equal to 9 plus 2. Now you can see this is 11 and this goes on this side. So V equal to 11 minus 5 is 6, written here. Okay. And this is still simple. F plus V equal to E plus 2. 20 plus 12 equal to E plus 2. So E is equal to, this is 32. 32 minus 2 is 30. This is given here. Okay. So you can see from the above table that F plus V equal to E plus 2. Okay. This relationship is called as Euler's formula. Okay. We have been using this and we will be using it even after this. Okay. Eighth one and the last one, read this very carefully. Can a polyhedron have 10 faces, 20 edges, and 15 vertices? Okay. You may come across such type of problems even in exam. So try to understand this very thoroughly. Okay. So we are directly moving to the answer. According to Euler's formula, which says F plus V equal to E plus 2, where F is number of faces, V stands for vertices, and E for edges, number of edges. In the given example, we have, see, F is 10 faces, vertices V is 15 here, okay, and edges E is 20. So you have to read this very carefully. See, they have not given order, okay. So you have to take this and understand this very carefully. Okay. Now we were here. F plus V is, we are trying to find the left hand side first. F plus V is 10 plus 15. 10 plus 15 is 25. This was left hand side, and right hand side is E plus 2, which is 20 plus 2 is 22. So left hand side is not equal to right hand side. 25 is not equal to 22. Hence, such type of polyhedron is not possible. So you can see the use of Euler's formula, that even from so much data you can say that such type of polyhedron is not possible. Okay. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of visualizing solid shapes, faces, edges and vertices, let me know through comment section and I shall solve it. Thanking you. Good luck.